So
Yes, just a kickstart in the streaming marathon. I already told Dennis the hopping now. I get even more respect of all the guys who they streaming the whole day with different streams.
and switching the language always
Yes, yes.
always quite a
And
challenge.
reaching, yes, of course. Yeah, today, yeah, have you again after the last Thinkers talk. I already tried to cut the video and make a tutorial out of it because it was that good. Lorenz Curve and all the other stuff binning, and then we had the idea. Yeah, let's do it again. Let's do some deep dive talk, especially focused on this. Yeah, and the
We
stage
want to
is
do it in
yours.
English because there was
Yeah.
some of the people saying, "Oh, it's hard to understand it in German." Therefore, we tried our best to do it in English. So, if you have questions, just let us know, and we will try to
Mhm.
answer the question, or me and Arthur. What's my plan for today? First, we will start with why I come up with binning, why I try to bin something, and we will have a look in the DAX formulas. We'll have a look in the how to do it and how to use it also with maybe different KPIs. Next step will be we are looking into the Lorenz curve. And last but not least, we will have a look into what is happening if we're using quite a lot of data. So we will not just using the 100,000 lines of data I've provided in my first model. We will do it with nearly 8 million. And we will see what the impact is on of this big data, of more big data to the performance of the formulas, because it's not the best thing if you have some X and virtual tables to use big data, because it's quite performance heavy. Therefore, we will have a look what is happening if we use a large amount of data or larger amount of data. And I will show you also a formula in a function in Power Query, which the function you can create random lines of data out of your data. So you can multiply your data just by using the function. And yeah, this was the plan for now. So I would say
Yeah.
I should start with
Mm,
sharing my screen.
Nice, Michael. Yes, I'm just waiting. You still have us on screen,
Yeah,
so
sorry,
I
sorry,
don't.
sorry. I
I don't. No. Yes, here we
now
are.
So we are jumping directly into our model. I'm using AdventureWorks, so the most should know it. It's a basic model of Microsoft. I just chose the data model. So we have sales, we have a date table, we have customers, we have regions, and we have products. And in our different approaches today, first we want to have a look at the date table because we want to bin something based on dates. And second, we want to have a look in the customers because we want to see what kind of revenue produces the top percent of our customers, the top 2% of our customer, and so on. This will be the part with the Lorenz curve. So, but jump right into our data and have a look at bins. So, if you want to say, okay, I want to know how many days are in my data having a revenue over a certain amount. So in this case, I want to see all how many days I have over 40K or something like this, or with exactly 30K. And the problem is, if you have a look in your basic data, you can't bin this just by bringing it together, because the granularity is much higher on this level. So if we look into our sales, so we see the data is not summarized for each day. So we need to summarize it to make to say, okay, we have X days with a revenue higher than 10K or something. We have X days with a revenue of exactly 30K. So to do this, we need some DAX. So here you see if I just bring in the revenue based on how many orders we had by revenue, it's really depending on which product they bought. And we know now on each day there are maybe 1,000 different customers, 1,000 different products, and we have to combine them to make an assumption or to make a rule how this can look for each single day. So I will delete this. It makes this a little bit bigger. And I have done this here in my dynamic binning. And we basically need two things. We need a series, so classical parameter series, to say, okay, we want to set it on a series. If it is 1,000, bring it on 1,000 and so on. And then we need our measure. And this measure, I will enlarge it a little bit, is practical, quite simple, because it does the same what I've described. It summarizes the data based on the granularity of the date. So our first virtual table summarizes the data based on the date. So we are summarizing the data for each day, and we say, okay, we want to have the total value for each day. Okay, this is our first virtual table, and I guess Arthur knows what is coming because we talk about virtual tables a lot in the next step. And now we have this virtual table, and the next step is we have to say, okay, if there is a certain value, we want to count this. And if we just sum it up, we can't bring this together because there are a lot of values between, for example, 1,000, 2,000. And therefore we say, okay, I want to round it to a specific value so that I can say, okay, this specific value matches one of the parameters in my table. And therefore can say, okay, I round this down or round to the thousands. You can also round down or round up. It's depending on your use case. I round just and say, okay, please round it to the next thousands. And now I know if the bin, so if this parameter meets exactly this requirement, I filter a table. So I'm filtering now my virtual table, and this virtual table then get counted. And because we're using this binning in this axis, we get this the value for each bin. And if I'm filtering, you can also see it's dynamic, so it's dynamically filterable from outside of this visual. This is also quite performant. So if I just go to the next model, and this model is exactly the same model, except that I have multiplied my data. So we are now talking about 7,858,000 and something. And here I have a binning. Okay, the binning is a little bit larger because the values are larger, but it's exactly the same. And if I click on something, you can see, okay, the performance of this binning is quite good. So actually, I would say this is something you really can use in quite big models. Arthur, you want to say something?
Great. No, I was just impressed how fast it is.
Yeah,
but,
we are
okay,
talking
but
about,
it's just binning. It's not the Lorenz curve, of
no,
course,
it's
but
not the Lorenz curve.
it's
just
still the main point or the main thinking challenges here. You have two axes and both are, like sums or counts and no dimension as an axis. This is the
Exactly.
difference to, traditional analysis and
Yeah. And of course,
splitting, clustering.
this brings also a disadvantage. So you can't filter. If you click here, it does not filter everything else. So you can't filter from this chart to other charts because we are not connected to something. Therefore, this is a disadvantage. But obviously, you can analyze your distribution, for example, of the days. How many days had 2 million, 4 million, and so on. So yeah. And I really was also surprised that this was quite acceptable performance. So as you can see, with 8 million rows, it's quite okay. I can also blew this up to 40 million rows, but at some point, it's a question if this is still a use case or not. But I will show how I multiplied my data. So I will show this later. So now let's go on. Let's move on. Now we have seen this. So other question, please just write your question in the comments. I will try to answer them.
I will shout out if something is on point.
Okay.
I will inform you. No questions yet.
Okay.
So I see
Let's
silent
move on.
watches.
And the next, and basically, I started for the next topic exactly with this dynamic binning of my data. So obviously, you can do this for all your KPIs or all your measures. So you could change this and can say, okay, I want to do it for profit. I want to do it for something else. So you definitely can change it. And the next step, the next thinking step of mine was, okay, now I know each bin and I know how many is in this bin. What is if I say, okay, I want to see this by revenue and I want to know which revenue was made by my top percent of customer, my second top percent of customers, and so on. So if you are if you have studied economics, there's something called Lorenz Curve. It's about the distribution of income in a country. So it says the top percent of people in the country have maybe 50% of the income. And you can do the same thing for your customers or your clients. You can say, okay, my top percent of clients are responsible for 10% of my revenue. And this was a question I asked myself, okay, can I do such an analysis dynamically with Power BI, dynamically with DAX? And the short answer is yes, I can do. So yes, I can do. So I performed this, and this is the final result. But now we will step into step by step what I did, and we explained the binning and the use of virtual tables is something I use yet now again in a little bit more, I would say, advanced way, because we are using dynamic tables or virtual tables and use them in a different way again and again. So let's have a look. So the end product will be this. So we can even use this in small multiples. We can also filter this. So everything is dynamically, and we see there's not so many rows which has to be calculated. And in this case, it's also quite performant. So we will see this later on the big data model. But let's jump into our data. And we want to start. So basically, I have three calculations, but all the three calculations have the same principles. So we always start the same way. Only what we are using as an output is changing. Once we use the revenue per percent, once we use the percentage of the total, so only the outcome is changing a little bit. So let's start with the percentage of the total. Arthur is smiling.
Yeah.
You already know
Nice
this.
measure. Yeah.
Yeah. And I want to know percentage of revenue per percent of customers. So I want to know which percentage does my customer have. And the first thing I need is, again, I need a table, a virtual table, and I use variables. And to be honest, I have no clue how I could do this without a variable. So I wouldn't, I have no clue.
You
I,
shouldn't.
yeah, I shouldn't. Yeah. And the cool thing is about variables, you can structure your code quite easy. You can say this is the first, second, and so on, and you can move like like a text. So we can start with our first variable, with our first part of the text. We need a group where we say, okay, we want to know the revenue per each customer name. We could also do this per customer key. So would be the same. Maybe it's better to do it for customer key. I now used customer name. And I said, okay, please summarize. So summarizing, creating a virtual table. And the first thing is I have to say which table I want to group or I want to summarize. It's the table sales. I want to use the granularity, and I use the granularity customer. So I bring everything together for the customer, and I say I want to know the revenue for each customer. So I get a new table containing all the customers with the revenue. So this is our first virtual table. We are starting with a table with all customers with their revenues. So second step is, because we later need the count of how many customers are in our data, I just said, okay, I want to use the customer table and say, okay, I need the count of all customer tables. I guess there's also, this could be a little bit easier made, but it's okay, because this is not the part which makes the data, which makes the performance bad. So I say, okay, I want to use all my customers with some revenue. So I only use customers which have at least bought one thing. So
And
they
then
have,
this is dynamical, right? Because it's a virtual table, the outside filters are passed in. So if you have certain filter of a country or
yeah,
region,
exactly. So
this is cool. That's why you shouldn't do it in Power Query and just
yeah.
remove the blank values there. No, you shouldn't, because this is a dynamic way.
So now we know the total number of customers, and the next step is a little bit, I would say, different thinking, because I was thinking about how I can get a percentage where the customer is located. And the thing I've came up with is say, okay, and maybe in the future I could use index instead of rank. I don't know. Should be possible. Why you're celebrating?
I'm hyping these new functions all the time, and I was just waiting if you also have use of them in your challenge here or
Yeah.
not. I wasn't sure, honestly.
Actually, maybe you can replace the rank X with index. So this should be a possible solution, but it's something I could try. But the thing is, what
Yes.
you definitely can do, and this is something interesting, you could use my results, the curve, and get the curve. I don't know the English word for Anstieg. The curve
Ascendance?
ascendant of
Maybe.
the curve. So you can make like calculate what is the difference between %1 and %2. So what is the differences between each stages? So you can make the deviation of the curves by using index, because you can compare each step of the curve. So, but this is, I guess, a little bit not needed.
Okay, that's what you show next month.
Yeah, maybe. So, and now we're going and say, okay, we have calculate our customer table, so all the customers with all their revenues. And now I say, okay, I want to rank them. And I want to rank them by the new column revenue. So this sorts me everything by revenue. We will see this is not perfect in this small kind of data set, but we're getting better if we have a big data set and have more not similar values. So we will see some small problems, because if customers have the same revenue, they have the same rank. And this is some kind of a little of problematic, but we will see this later. So now we say, okay, each customer get an own rank. So we add a new column for each customer with an own rank. So now we know, for example, the top customer gets rank number 1 with 1 million euro revenue. So the top customer is set here. Next step is we do not want to see every single rank. We want to see the share of percentage. And now it's coming into play that we calculated our customers total. And we know if I calculate the customers total, I can divide my rank by my customers total, and then I got a relative position in the total things. Yeah, delta, thanks. And then I get the relative position of my customers in my data. So now, for example, I say 1 divided by 100, because I have maybe 100 customers. I got the relative position 001. So in this I do for all my customers. So I create a relative position by calculating all my customers, dividing by as the rank of the customer, dividing by the number of all. So this provides me with a relative position of the customer. of course, this can be much more than 1%. It's going to be 100 something. And the next step is I say, okay, I round this. So I round this always up. And I say, okay, if I'm in 001, I'm in percentage 1. So I round this to total numbers, to 1, 2, 3, and so on. To later compare this in my data. So this is a step where we creating, let's say, rank, a classification. So class A, 1, 2, 3, and so on. So here you could also bring in that you say, okay, I can use this also for a ABC analysis. So next step. So now we know, okay, each customer has a rank. Each customer has a percentage place where it's relative in the data. Now we can say, okay, we create a table which is summarizing the virtual table. Now we're going and say, okay, we create a summarization of the virtual table. So we take this table, we created cast position here, and say, okay, we use this cast position and say, okay, we summarizing the percentage and calculating the total revenue for each percentage. We now got a next virtual table which says, okay, in this virtual table we know for each percent how big was the revenue, and this helps us later to say, okay, we can use this virtual table to now say, okay, I want to bring this in different contexts. For example, I can say, okay, which percentage has how many revenue and so on, and how is the share on the total revenue of this percentage. And here we are creating and say, okay, we use again a parameter table and bring this parameter table in from outside and say, okay, there's 1, 2, 3, and so on. And we always want to calculate this table if our percentage is smaller than our value we are providing from outside with the parameter. So, and here we're seeing this is our new table, and this new table then gets summed up, and in the end we calculating the total sum until this point and dividing this by the actual total revenue, because the revenue here is only filtered from outside, not filtered from anywhere inside this this formula. So, and when we have done so, we are going just to this chart, and here we see, okay, I used, this is a curve, this is the formula I described. So it's always calculating for each percentage what is the total amount, total revenue before this percentage in our virtual table, and then divides this total revenue by the absolute total revenue. So if I say, okay, for example, if I click in Australia, we see everything is filtered in Australia. And something I then brought in is just another parameter that I can say, okay, I want to slice to 50%. And now I see, okay, on 50%, I got 95% of my revenue. So 50% of the customer are responsible for 95% of my revenue. And here, this is also done with two types. One is I brought in a X line, so a constant X line, which say, okay, please mark this constant X line, and this is basically the parameter here. And the other thing is I brought in no. I brought in here a new filter, so a new measure. In this measure, you can see it's exactly the same until here. And here I just say, okay, this value is exactly our parameter. And then I just came up with these parameter. And here we can then see two lines. One is calculated dynamically for each percentage, and one is calculated exactly for this parameter. So we got always the possibilities to slice and dice and see what is on this line. Yeah, and here I use just a little bit colorization, say, okay, if the bin is under or over, it's white or blue. So, and the cool thing is, you just can use it with combination, for example, like small multiples, as I can see here. It also works perfectly with the use of parameters, as you can see. So you have a lot of possibilities to really analyze the risk or the potential of your customers, of your products. So you can name it what you want to use as as something you want to analyze. What is the impact of your top 10% on revenue, on profit, or something like this. Well, so this is more or less the basic settings, and we see a lot of we see sum X, we see virtual tables, we see summarize, and it works, but obviously this is not a solution you should use if you have huge amount of data. So if you have real massive amounts of data, this is not the thing you should go to, because this is really computing a lot of things in the back end. And we just can have a look what is happening if we look at bigger data. So I've done the same. So I have another map, and now you see, okay, this is not calculated on 70,000. It's calculated on 7 million. And first thing, how I created this is I just used a Power Query function. So if I go for transform data, I created a function, and this function name is random values. And with this function random values, I can calculate a list, and this list is multiplying our data. For example, I can say I want to have 25 as a multiplicator, so as a factor. I want to start with a range of 50. I want to end the range of 150, and I divide it by 100, so I get values between 0.5 and 1.5, and I now can say invoke, and I got a list with values between 0.5 and 1.5. So and this function can be used in my data. So if I go for my sales, I just can bring in this function and say, okay, for example, here I invoked this function and you got a list. And next step, if you expand it, you got, in this case, I used 100 rows. So now I got every row 100 times, and I can multiply it with a random value. And now the question is, why multiplying it with a random value? Because if I don't do a multiplication with a random value, the Vertipux engine is really good in compressing the data and is really performant. And to challenge this engine, I said I want to have a high unique column, and therefore I just said random value also bring in to make it harder to compress the data. And therefore I brought in this little function. You can also find this function in a LinkedIn post for me, because it's quite helpful if you want to test against big data or bigger data. You just can use this function and it will just create a list with random values. Also, if you want to anonymize, you can also use this function, obviously. Okay, so, but now let's have a look in, don't change, discard changes. Yes, so now we can have a look into this data. Now we can say, okay, what is if I go and say, use this kind of data, and I refresh this, and you see the is going on. It's using a while, and of course now the DAX query is much slower. So you need nearly 5 seconds to calculate everything. But I think, okay, we're talking about 20,000 customers, and we're talking about 8 million rows of data which has to be compressed. So I think it's not the worst thing ever.
Yeah, it's still, if you need, it's Yeah, it's worth it if you really need it for use case. It's not a highly dynamical dashboard, but
Yeah, yeah,
it's an analysis. It's much easier to do this than to run some code to wait. This is, I think, the other side.
yeah. And now obviously we can also check it, and I have brought it into my DAX studio. So let's run it here. So this is just the code behind the chart, and as you can see, now it's running. So waiting for the query to end. I tested this before; it was faster.
Yeah, okay, we're in the stream now. So in Thinkers Talk, some things also have been more slow than normally.
Yeah.
Yeah.
Yes, yes, yes. But the cool thing is I can just show I did it here. So this is a measure I showed you before. And one thing I did is I just pasted in the measure and I say, okay, I can check each step. And as you can see, if I check the step return and change the outcome for the percentage table, so I would say one of the heads of this whole formula, I can say, okay, present me the percentage. So I got one with 22 million. I got two with 1.53 and so on. And you see it's monotone falling. So this is exactly what it should look like. So here you can test each step of your formula and say, okay, in this step, the formula makes exactly what I had expected to do so. So this is really helpful to say, okay, we can see how this is calculated internally. And maybe now I'm finished. No, I run it again. So here you see the results. Okay, and we should see the server timings.
If it takes way too long, then you maybe can stop sharing and just for a few moments to run this.
Yeah, but it's not. We have seen that it works. But you can also see the query plan here a little bit. So if I go server timings, you see what is needs the most time. It's basically this step where you bring in dark mode all the way. Yes.
Yeah, I even have this normal CMD as a light mode. I think I'm the only person in the world who has changed the color of the normal bash in Windows, just because I hate dark mode. But it's okay when others use it.
Yeah. So basically, you can you see that the main step is the first summarization. So this is a step needing the most time here. So this is the real heavy step to bring in all the data in this first table. So if you have less data in your first table, so if you talk about products, for example, it will also need less time because it's easier to summarize the products than to summarize maybe 20,000 customers. But this is also meaning if you have like a B2B, B2C business, this is maybe not the thing you want to do. Maybe if you have B2C, you should pre-aggregate your customers or something like this and shouldn't perform like completely dynamic analysis on your customer, on your client base, because this is then really smashing the performance, I guess. Yeah. Yeah. Okay.
There is also an advanced question from Fernando concerning your random function.
Yeah, you can. Can you bring it in?
Yeah, maybe you can go back to this later. It's
Could you have
about
said?
if it's
Yeah, I could also just multiply this. It's also possible.
okay.
So if I go here for transform, I also could use this function. So basically, it's the function behind this. If I go to advanced editor, I basically say, okay, I create a list So here I create a list,
Mm,
and this list is long as a factor. And in this list, then I say, okay, bring in different values, and this is here. So the random function is
mm,
here. So here, random between. So this creates a random
mm,
between. And I say, okay, start with a number, end with a number, and it just brings in something between this both
mm,
numbers. So I can't say what number is coming out. And I then divide it
mm,
by a specific range. So I could bring everything to 1 if I say 10, for 100, say start with 1, end with 1, and range end with 1. And if I invoke, I just get everything as a 1. And if I
okay, but it's all the same, but it's you cannot make it random, but also reproducible, for
no,
example.
no,
Okay.
not really, not really.
So
So
it's
if you
something
run,
you do in like in data science or stuff, but okay, no,
no,
not in Power Query.
no, this is just creating a number between two random
Mm,
ranges. So you could also come up with whole numbers, so everything is possible, but basically it creates
mm,
random numbers or
okay,
random fractions of numbers. So, but not really possible to say exact. It's not reproducible.
okay. So maybe Fernando's question is I can understand why he asks it because it's maybe you are lucky with your random numbers and this one performs better than when I do it. It performs very bad
No,
because the
no,
random
no.
numbers are different. I think in a big pieces of data, it doesn't really. It's
Yeah,
not really a
well,
difference.
because the thing is, it's about the granularity, and
Mm,
I just want to have a high granularity in this revenue column, and it's I guess it doesn't matter which numbers they're in because the granularity goes up, and therefore it shouldn't matter at all. So
mm.
yeah, I
I
didn't
don't
know.
even know if there is a seed functionality in Power Query.
No.
But there is a question in the community. Just fast googling shown me that, but I don't think there's something like inbuilt.
Okay, so and last, now we got the proof. We're seeing that all the data is monotone falling because
Mm,
every percentage has to be bigger as its next percentage. And here we see this is the case in our data in
mm,
the one if we're using the 8 million rows. Yeah. So yeah,
nice.
this is
Okay.
how.
Just this. So it's so easy. Uh,
Yeah,
yeah,
quite
nice.
fun.
But I've
Yeah,
seen this twice now, or I think even twice, because when I cut the tutorial, I've seen all this a second time, and it seems so easy when you explain all the steps, like step by step.
yeah.
So it's quite okay. It's not so complex to see it, but yeah, the outcome is something crazy, and you really need to have an understanding about this all the virtual tables. So
Yeah,
what do
this
you
is
want to have?
this is exact, and this is something cool. What I can really I not really use, but you can use obviously. If you have DAX Studio, you can click. You can say, okay, I use my formula, and you can
Mm,
perform the results of every single step of your formula. So I can say, okay, I want to use. I don't want to use my percent table. I can also do this for my customer position. So I can copy this and say, okay, please provide me the result for this one. Now it's going to the data and performing this one. And now I get the percentage and get the ranks, and everything is calculated for this one. Here you see the last ones and the top ones. So now you see the virtual table is realized
mm,
in DAX Studio. And this is also a way how you can prove that your calculations and your thinkings are right.
yeah, yeah, or you can just use the toCSV function and print out your variables.
There's
Yeah,
list random. There's
yeah.
ah,
There is actually a seed. Wasn't relevant for this, but thanks, Fernando. So it is possible to create reproducible but random data with this function. Nice. Thanks, Fernando. I also didn't knew that. But then you can make fair challenges with when you
yeah.
need to test something again.
I can rewrite the function so
Yeah.
that you can use the function with the same seed
Mhm.
everywhere. Yeah, but obviously this is a solution. This is
Yeah.
this is the end.
Yeah. Thanks, Michael. I posted the link. So if there are any questions who want to talk live to us, there is the chance now. But I will not keep it too long because it's cool when it's such a good tutorial is on point and all the off-topic stuff we can do
In the end,
afterwards in my backup stream. So this is quite good. And as we told, the use case is live analysis. It's not if you just need to cluster and you know around which dimensions you want to cluster. Then yeah, use Python and use R. Just use data science. You don't need it live. But if you really need to analyze if there is maybe some self-service inside, you have this all these measures, but you do not know which dimensions are more important, as you told already. Sure, is the customers primary the important or the products?
yeah,
So it depends on the business. So if yeah, the end user maybe know this better than you, then this is the way to go because it's so easy here to replace the dimension by parameters and you have a whole different analysis just with the same calculations.
yeah,
This
and you
would
know
be much harder when you pre-calculate this. You have to
yeah,
imagine all these constellations that are relevant, and you never know. You always miss something. So
and
for
now you
this,
can
it's
also make some filtering here.
yeah, yeah. This is you cannot. The data analyst may not know all the details, and this is why Power BI is so strong in this case.
Yep. Okay.
Okay,
Yeah.
yeah. Thanks a lot, Michael. I enjoyed it to see it again. And thanks also to all the viewers. We like to share it with you and just keep in touch with Michael and me on LinkedIn and yeah, ask questions. Questions are always inspiring to do some crazy stuff like this. And yeah, maybe meet again. Merry
Yep.
Christmas and a Happy New Year.
Goodbye.